So we are going to continue our discussion about the measures of variability for our data sets. And we've already talked about the range, which is a pretty simple calculation, the interquartile range, which is not as simple but still a determination of the middle 50% of our data, how spread out that is. And tonight we're going to talk about the mean absolute deviation. So what is the mean absolute deviation? The mean absolute deviation is going to sound a little complex, and the process is somewhat complex, but really it's telling us how consistent our data is. It's telling us how close we are to the mean. And before going through the explanation of the calculation, I'd like to just do it because I think that you'll find that once we do it, it kind of explains itself. So let's look at our problem here. Jason wants to compare the mean height of the players on his favorite basketball and soccer team. He thinks the mean height of the players on the basketball team will be more consistent. That's supposed to say. He thinks there will be a greater variability in the heights of the soccer players as compared to the basketball players. Let's see if he's right. The first thing you want to do is create a dot plot for each team. So why don't you go ahead and do that on your own and come back and check with me. So we had for the soccer players, the lowest was a 65 and the highest was a 78-inch height. For the basketball players, the lowest height was 73 and the highest height was 84 inches. And what we can see is we definitely have a definitive mode for the soccer players, and the mode for our basketball players is a trimodal set of data. So go ahead down below, pause again, and figure out your mean, median, mode, quartile 1 and quartile 3 for these basketball players and soccer players. Okay, so I got all that data here, and hopefully you got the same answers as I did. So we had 3 modes for our basketball players and 1 mode for the soccer players. If you agree with me with the median, quartile 1 and quartile 3, go ahead and make a box and whisker plot for each of those. And if you don't agree with me, then maybe you should go back and check your calculations and see if you can come up with what I came up with. So pause here and create a box and whisker plot. I have my box and whisker plots here, and notice I have titles, as should you. If we look and analyze these box and whisker plots a little bit, we find that the whiskers of the soccer players are definitely longer than the whiskers of the basketball players, but the middle 50% of the basketball players is more spread out than it is for the soccer players. So let's take a look at how this would be represented in our mean absolute deviation. So go ahead to the back, and we are going to carry forward some of the information from the front. So go ahead and fill in your mean for the soccer players, which was 72.4 inches, and the mean for the basketball team, which was 79.4 inches. Now this part of it is long, but it's not necessarily difficult. Basically what you need to do is you need to fill in all the heights for the basketball team members. And I apologize, this is kind of out of whack here, but basketball team goes over here and soccer team goes over here. So the basketball team, we're going to fill in all their heights. 73, we had a 75, and we're just going to go down along the line. 78, 79, 79, and so on. So you can go ahead and fill in all these heights. Then the next thing you need to do is go through and find the difference from the mean. 73 minus 79.4 is negative 6.4, and then we take the absolute value of that, and that's where the mean absolute deviation comes from. So that's going to be 6.4. So 75 minus 79.4 is going to give you negative 4.4 or 4.4 here. Okay, so you're going to go ahead and you're going to fill out both of these charts using all the data from the front. We have all the data filled out here. The middle column represents the difference, and then the third column represents that absolute value of that difference. Then you're going to go ahead and you're going to find the mean of all of these. So you can add these up and divide by the number of scores. And that's going to go in the last box. So you can pause here and do that on your own and check your computational work. The mean absolute deviation of the basketball players was 2.75, and the soccer players was 2.453 repeating, so 2.45 approximately. I got a sum of 33 here if you want to check, and a sum of 36.8 here. So that gave me 2.453 repeating, and this was 2.75. So what does this mean? Well, it looks like my mean absolute deviation of the soccer players is less than that of the basketball players. And basically that tells me that the heights of the soccer players are more consistent. The mean absolute deviation basically gives us a measure of consistency. Soccer players' height is more consistent than that of the basketball players. There is a page in your practice packet, I believe, that looks like this, and I would like you to complete that. It's actually 2 pages to practice dot plots and mean absolute deviation. I'll see you all tomorrow. Have a great night.